input and output side of your application, right? So this is kind of like the core idea of what guardrails are. Very briefly, this looks like a complicated diagram, but I think the core idea to take away from this is that as you build more and more sophisticated AI applications, such as code programming agents or multi-turn chatbots, etc., or co-pilots, the idea of guardrails is pretty extensible, wherein you typically would pepper that throughout your AI architecture, right? So let's say this is a customer support agentic, like an AI agent for customer support framework, right? So what you would typically do is, like, as you go through this pipeline of a customer query comes in, you'd basically pass it through an input classification guardrail. As the support assistant generates an action, you essentially go through an action validation guardrail. As you kind of like execute that action, you see like, okay, was the response that was generated desirable? And so you go through that response validation guardrail, right? So this entire idea tends to be like pretty extensible, and how guardrails are used within the application tends to be much more tends to kind of like grow with the level of sophistication of the application that you have. The other thing I want to quickly highlight is another way that people typically add reliability via guardrails is by just adding them directly onto your AI platform. So let's say as you're building AI applications, you end up building like a centralized AI platform to make it easy to just use AI, or parallelly work on or build a bunch of different applications. This tends to be typically the case at, if you're working in larger organizations. So a very common pattern is to typically add guardrails right at the source of where your LLMs are being used, where if you have any sort of AI gateway, you would essentially add like a guardrailing layer around that gateway, so that throughout the organization, instead of using, raw, unguarded LLM endpoints, you essentially like use that same functionality in chatbots, in RAG applications, and agent workflows, whatever your way of using and building AI is. But instead of using that raw endpoint, you essentially use, this guarded endpoint. Awesome. So that's a little bit of the foundation of, like what guardrails are. One of the things we haven't really touched upon is like how they really work. And what I'm going to talk about is like not all guardrails are created equal, right? And this is especially the problem because like a lot of times these guardrails are essentially looking at verifying like policies as part of the checks that they're performing. So hallucinations, etc., all of these are policies that you want to apply to your AI application or your AI platform. And then to detect all of these policies, it isn't typically a straightforward, problem to verify or validate. So typically you have to build a machine learning model in order to attack that problem well, right? So how this can look under the hood is you can basically have a rules-based or a heuristic system. This tends to be, only for, I would say like the most kind of basic problems, but tends to, work really, really fast, but not be as flexible in terms of what it can attack. So typically things like regular expressions or pattern matching or keyword filters, this can dictate part of your guardrail. So let's say you have a guardrail about, no PII is allowed to be leaked. You can detect what PII looks like what a phone number looks like, for example, by doing like regular expression matching. Some guardrails, most guardrails, in fact, tend to be small, fine-tuned machine learning models, especially if you look at, things like factuality. So detecting when there's a hallucination, you can do this by using like a smaller fine-tuned ML model, or classifying the toxicity or, language, etc., used by an AI model or an input going into the prompt. That can basically be done by, like a traditional small fine-tuned model. Topic detection to detect what is the subject matter that, the chatbot's talking about or the AI application's talking about, or even detecting like any sort of named entities. All of that, can be done by traditional small ML models. And then finally, if the problem that you're trying to catch with guardrails tends to be much more, complicated or sophisticated, you can also use a secondary LLM call, right? So for example, like, are my chatbot responses coherent across multiple sentences or coherent based on what the input was? That's a much harder thing to verify with, just a small fine-tuned machine learning model. So this is one of the things you can do with using a secondary LLM call. Similarly, like rating the tone of voice used by an LLM, right? Like these tend to be much more fuzzier and therefore tend to be much harder problems in from a machine learning perspective. Most commonly, what you'll see is that a guardrail typically uses a combination of these approaches, right? So you'll have like a waterfall like system where you can see if you can kind of like build a high confidence estimate of whether the undesirable behavior you're trying to catch with guardrails can be detected with like some of these simpler techniques. And if not, then you know, go towards the slower, more expensive, but like typically more flexible technique, and you end up kind of like building an ensemble. Awesome. So with that out of the way, as with anything machine learning, you know, it's very important to understand how effective and how performant the machine learning system is. And this is where, you know, the subject of this talk really comes in, which is that we, you know, made a huge amount of like investment in the open source, like basically building out a comprehensive AI guardrails benchmark that is essentially intended as this, you know, like useful tool to help you decide like which guardrails are most relevant and what performance trade-offs you're really making when you're adding guardrails to your framework. And you know, that's what I want to kind of like, you know, shed light on and share some interesting findings, etc., that we have, right? So what we ended up doing is especially because like people talk about guardrails but you know never really talk about like how performant they are, you know, what the latency to expect is, how accurate or how, you know, how many of the risks can guardrails really catch. So this is where, you know, what we did was we created like 6 tasks which represented the most common tasks that we had seen on our, you know, open source guardrails hub is like being the most popular task for which people use guardrails. And then for these 6 most common, you know, guardrails tasks, we essentially like curated data sets, picked up the most common guardrails that you can use for this, either by using open source, you know, models, by using our guardrails, or by using, you know, like some verification endpoints using the cloud providers, or by prompting OpenAI, etc. And then we kind of like shared what our findings was. So that's, you know, some of the effort required here. So in this talk, what I'm going to do is I'm only going to focus on these 2 just in the interest of time. So PII detection benchmarks and then jailbreak detection benchmarks. And I'm going to skip over these 4. But if you're interested, you can find the entire report, you know, just publicly available on index.guardrailsai.com. So I'd encourage you to check that out. Awesome. So let's look at PII detection guardrails and you know, like what our interesting findings there are. So the task here that we're trying to solve with the PII detection is essentially protect personal data if you're building any AI application in financial services, in healthcare, HR, legal, and call centers by automatically masking sensitive information, right? And especially if you're working in using AI for any of these regulated industries, you'll typically find that this ends up being like a huge blocker in successfully adopting and getting the type of reliability that you need, you know, from generative AI applications. And so what we did was we curated a data set, and I'm going to talk in a second about, you know, the data set that we curated. And we then, essentially benchmark like 3 providers here to kind of like talk about how effective guardrails are. So one of the most interesting findings for me here was, you know, looking at the performance of Microsoft Presidio. Microsoft Presidio tends to be one of the most commonly adopted things you can find if you want to mask PII. In fact, you know, we have it available on our Guardrails hub as well, and you know, we like using it. I think it tends to be like really popular. It's very easy to use, very fast, very cheap. And then we benchmark Microsoft Presidio, you know, a leading OSS model that is, you know, transformer based. In contrast, like Microsoft Presidio is, you know, kind of it's like more rules based or traditional traditional NLP techniques based. And then we also benchmark like a new PII guardrail that we ended up building, which was kind of like a ensemble of, you know, a lot of different types of techniques for catching PII. What we kind of found that even with Microsoft Presidio's adoption, like even with everybody using it, like nobody really benchmarks how effective Microsoft Presidio is. And then we found that like, especially if you care about like F1, precision recall, accuracy, any of those like more traditional ML metrics around performance, Microsoft Presidio isn't the most performant, you know, way to mask PII. And not only is it like not very performant, it's also objectively like a lower number, right? Like if, for a machine learning audience here, F1 scores like a 0.37 of an F1 score is objectively, like not very high. And we're used to seeing these numbers like be much higher typically for, a lot of the ML models that we use in prod. So this was actually a very, very surprising finding for us. We found by just switching to, more sophisticated machine learning and deep learning based systems, we were able to improve on the F1 scores of Microsoft Presidio by 75%. And in a second, I'm going to show you guys like where a lot of that lift comes from. But we kind of found that even if you look at latency, right, because Microsoft Presidio uses like these really small rules-based systems, etc., the latency tends to be like really fast and really reliable, which is one of the best things about Presidio. So this is like about 15 milliseconds here. But, if you're looking at like just what's perceptible for the human eye, even though we have a roughly 4x higher latency when you're running our guardrails on GPU with like 64 milliseconds, 64 milliseconds is still in the range where, this is like not really even perceptible to the human eye. So even though on paper that latency is higher, you don't really get like too much of a slowdown when you in terms of like perceived performance. Let's look at the data set that we used this on. So we actually used like the data set created by AI for Privacy Organizations, PIM asking 300K. This data set is linked in the report that we've published on our website. And then what you can really do is like break down PII by these categories and then kind of like see what the performance ends up looking like, right? So straight off the bat, one of the most fascinating things for me here was that person, which is, like your name, essentially, if a name pops up in a statement or a data set or something, it's one of the most common things that people think about when they're thinking of PII, like you want to mask out, a username, etc. And then interestingly, this is also one of the areas where PII has one of the lowest, like numbers objectively that we'd kind of seen, right? So across the board, the performance tends to be higher across, some of these other categories. But for PII specifically, like we're basically seeing this like very low, like 0.1 score, which, is objectively like really, not very reliable. Compared to that, like Gliner actually ends up getting the highest score with like a 0.45, and then we're not far behind with like a 0.44. And then for a lot of these other categories around email, phone number, etc., these scores tend to be much higher and tend to be in the 90s or 80s range, which again is like if you're using machine learning models and systems, like in the 90s and 80s range is like what you're typically more used to. Awesome. The second category we're going to look at is jailbreak prevention guardrails. Again, one of the biggest, kind of like most common concerns that people really have around, like unreliability with AI systems. And the task with like jailbreak prevention is essentially mitigating the risks of jailbreaking LLMs so that they can bypass safety measures or produce restricted or harmful content, right? So what we did here, again, we curated the data set and then we benchmarked 4 models. So Meta's Llama prompt guard is the first model we benchmarked. Anthropic, this is actually an interesting one. So Anthropic doesn't officially have a jailbreak prevention model, but they released like a prompting guide that talks about how you can use Anthropic models for jailbreak prevention. Microsoft Shield prompt, and then finally we created our own, jailbreak prevention model, which was, transformer based. And then what we saw here was that if you're looking at Llama prompt guard, immediately like these numbers should stand out to you, which were once again like really surprising for us, which is that both the true positive rate and the false positive rate is 1, and Llama's prompt guard tends to be very, very skewed towards always predicting a positive label, right? Which again, if you're looking for like accuracy, if you're looking for precision, like maybe not the best behavior that you're really looking for. Compared to this, like if you're looking for like the most successful, like true positive rate, or if that's kind of like the metric you want to optimize for, we interestingly found like this contender with Anthropic surprisingly having like pretty good performance. So if you were just to detect jailbreaks and the metric you care about is like your true positive rate, and you do this by prompting using Anthropic's like Claude model with prompting, you would essentially see like one of the highest true positive rates we've seen, like one of the best kind of like trade-offs between true positive rate and kind of like just I guess accuracy would be like a more consolidated way to kind of like talk about the true positive and false positive. Microsoft Shield Prompt surprisingly like didn't really have as robust performance here. And then with Guardrails, what we tried to kind of like maximize is the overall balance performance between like if you're looking at the area under the curve, or if you're looking at F1 scores. And so we ended up kind of coming out the winners here on these two metrics as well as on accuracy. In terms of latency, Llama Prompt Guard had the lowest latency here with like 52 milliseconds when running on a GPU. And then we're not far behind with like 54 milliseconds, right? And a big part of like the work that we've done in creating this index is making sure that we share the data set publicly, we share the breakdowns publicly, etc., so that you can independently verify all of the metrics and results we kind of came up to. So this data set is also available on our report. We essentially found like this big gap in all open source data sets that we looked at for jailbreaking, where they had this over-representation of this like one single type of jailbreak category, which is role play, pretend, hypothetical. So if you're familiar with like Dan style attacks of jailbreaking, which are essentially like your an LLM, like a do anything now kind of style of attacks, where you kind of like grant permission to the LLM to kind of like follow your instructions. We found those as being like the most overrepresented categories in the open source data sets that we looked at. So a lot of the work we did here was really kind of like taking these data sets and then balancing them out so that we also have these categories right represented as part of like the jailbreak metrics that we're looking at. And these are, by the way, like non-overlapping, so one data point can belong to like multiple categories. And so you see some of that kind of like coming up here. Cool. So I'm going to close it out. The key takeaway from this keynote that I want you to think about. We see a lot of people using guardrails, and there's a lot of like ways to add reliability, but like none of it, even though a lot of this is machine learning based, like none of it is really very grounded in numbers. So the main takeaway I want you to take from this keynote is that guardrails and any AI reliability framework you'll use under the hood are basically machine learning models, and that you should benchmark every single ML model that you should use. And if you're interested, you can check out the full report here at index.guardrailsai.com. Thank you so much.
Amazing, Shreya. Thanks so much for doing this. And as always, what an incredible talk. This stuff is so important if you're trying to put AI into production. And that's why I always appreciate you coming on here and schooling us through this. In the meantime, I am going to let folks ask some questions. I know they'll start trickling in, but I can ask while we are waiting for people to ask these questions. The stuff that I'm thinking about really are like, at what point in your development cycle should you be thinking about guardrails?
Yeah, that's a really great question, actually. And very candidly, I think this is also where, like generative AI is like continuously evolving and such a new topic. And then every week there's like, 10,000 updates that happen, right? And so our opinion on this has also evolved from like when I first like launched the open source, like almost 2 years ago now. And so what we've seen as being the most successful points at which you really should think about guardrails are like, one, when you're really thinking about kind of like enablement for your organization, like AI enablement for your organization. So really, anytime you're thinking about like, hey, I work at this organization and I want to use enterprise AI, and I'm building like a centralized AI platform that has maybe like an AI gateway, AI model gateway, a vector database, etc. I think we've seen like a lot of folks like really add guardrails as like an essential component of that AI gateway, so that every model router that you're using or model gateway that you're using, so every request that comes through that is guardrailed. I think that's one of the most kind of like important points. And then the second one ends up being like, typically right at, if you've developed an AI application such as RAG chatbot, AI agent, whatever that may be, as you're going into production, essentially making sure that you have a lot of this like preventative measures such as guardrails, before you ship to prod, as a key way of enabling like prod deployments. I think that tends to be the other kind of like crucial one.
So there's some questions coming in here now. How are you creating testing data?
Yeah, Yeah, that's a good one. I think in terms of test data, I'd actually recommend like looking at the report here. For a lot of these, we either looked at what are open source data sets available. If there's a really good data set available, we didn't we basically use that and then kind of like update that. So PII is a great example of that, where there is a really fantastic PII data set available. For other ones like jailbreaking, for example, we found that there are open source data sets that have some good and some bad things, but they require a lot of like augmentations, curations, sampling, filtering, etc.
Mm,
And so we did a lot of work there in kind of like creating the right data set. So jailbreak detection has one of those, and then we also kind of like share details about like how we curate or created the data set like in the report there. And then for some other categories, so I didn't talk about it in this report, but like for I believe it's for the off-topic conversation or restricted entities kind of categories. The most effective thing we found was to like create a new data set from scratch. So there wasn't any open source
nice.
data set, any public data set that we saw that we could use there. So here we ended up kind of like creating our own data sets.
All right, so I've got one more great one for you from Joe in the chat, and he's asking, what's the trade-off between cost and latency versus safety? Are there ways to observe and tune that with guardrails?
Yeah, that's another great question. I think in general, I would say that there's no one universally applicable answer for that question about like trade-off between like cost and latency for safety, because every like safety means different things to different people, right? So for you, for example, going back to this information about categories, for you safety might mean like no jailbreaks and no hallucinations, whereas for someone else it might also include content moderation. And the
Mm,
more categories you add there, the more kind of like this the more your cost increases, or the more kind of like latency increases, depending on how you've orchestrated your framework, right? What we have really tried doing with our open source is make it so that you can like add as many guardrails as you want without necessarily needing to increase your cost, because we essentially have implemented a lot of the foundations you need for parallelization and latency optimization. I think the cost at the end of the day really depends on what models you're using as part of your guardrails, and that's also where this index can kind of like be a helpful like tool and assistant. So if I look at jailbreak prevention here, I talked about how Anthropic had like surprisingly great performance. What I kind of like didn't touch on is like if you look at this number in this column here, right? Anthropic also has, I think this is like what 40x or something like worse latency, and also one of the most expensive models that we kind of like tested for.
mm,
So there tends to be like this, again, like this trade-off between like what you really care about. And then we didn't include like cost numbers here because a lot of these are, for example, like GPUs, right? Like it depends on what your GPU rate is with your cloud provider, and that kind of like really varies. But we have shared like the data sets and the models, etc., to do a lot of this benchmarking. And so if you want, you can kind of like reproduce a lot of that, and then with your cloud provider like test out what this rate should be. Yeah.
excellent. There's another great one coming in here about the best way to protect some case specific PII that
Mm,
wasn't present in the data set. And another
mm,
person just in the chat, I think we can drop some links to use cases or case studies that they can go and read later too. But
mm,
that question was best way to protect some case specific PII that weren't present
mm.
in the data set.
Interesting. I would actually say that I think the PII taxonomy, this one, so this we kind of like selected the top, I think this is 10 or something. We selected the top 10 just to kind of like include in the slide. But I think in our report, there's about like 18 categories or something here. I
Mm,
would, if you're thinking about like some category that isn't present here or some case that isn't present here, I would first double check with the report that has the full numbers and see if that's a category that's present there. And if there is, then you can essentially just check like which model performs best, right? And then just use that off the bat. If you check that and that's something that isn't present, what I will say is that your best bet is using like something like a named entity recognition system or like a regular expression based system. And those tend to kind of like, be extensible and flexible enough that without needing to do too much, they'll give you like good performance. I think with PII, the key thing is that, these models tend to be like local, like, so you can't really use an LLM for this because, you're just I guess like passing on the contaminated PII containing data like to the LM as well.
Yeah.
And so it's not really possible to use an LM here, but I would recommend using either like a named entity recognition model, or like figuring out if you can solve this with like regular expressions. For named entity recognition, we actually have, I didn't talk about it in this keynote, but like we actually do have like a pretty performant model here. Again, if you look at the report, you'd be able to like find links to it and everything. So I'd recommend checking that out as well.
Very cool. So last one, just on a practical level, should guardrails, I get a feeling the answer is a bit of both, but you're the one who knows more about this. So do guardrails always need to be created per task/objective, or can it be at an enterprise level?
That's a great question. I love that question. Okay, so I think there's different schools of thought on this. And there's, I think Meta's Llama, for example, has this one school of thought where you can have like one guard model, right, for everything. And that's also where you see like llamas, like like Llama Guard, for example, is like one of the most common models there. And then our approach is much more, no, they need to be like they need to be like kind of concern specific, like one guardrail per thing that you're kind of like concerned about. I'll talk about like why we believe our approach is like the right way, and we're trying to see with like Anthropic's constitutional classifiers that just came out a couple of weeks ago, or even the OpenAI release yesterday. We're starting to see a lot of these large AI labs also align onto our way of thinking, and I think the big reason for that is like you just do not have consistent things that you care about in a universal setting, right? So that's definitely not true in a global sense. So maybe for like, for example, in a use case like hallucination might be really a liability if this is going to be something that's customer facing, but for creative applications or for AI companionship use cases, hallucinations aren't necessarily a bad thing, right? So you tend to get these trade-offs. But even within an organization, if your AI application is internal facing versus customer facing, you're going to care about different things. Or if you are in a regulated industry versus not in a regulated industry, you're going to care about different things. And so I think that's why it tends to become like really hard to have like, okay, for this organization, you just need this one like guardrail, and that's kind of it. There can be this kind of like common, what do you call it, like common guardrails that you apply just for everybody within the organization. So, for your org, you can say like, okay, every LLM request, whatever application it's used for, we should make sure that, there's no content safety concerns, or there's no jailbreaking concerns, or PII, right? So those three you just add to your, guardrails proxy for the entire organization, but you still will end up needing like some specification like per application and then per industry, etc.
Well, a huge thank you, Shreya. We're going to keep it moving, but this was awesome as always. And there's more questions coming through in the chat. So if you have a moment to jump over there and answer them, I'm sure people would appreciate it. If not, they can reach you on LinkedIn or Twitter
Yeah,
or X.
absolutely. I'm going to stick around and then, answer a few more questions. But thank you so much again, Demetrius, for inviting me, and for everybody for your questions.
All
I'll see
right,
ya.
see you later. So now we'll keep it rocking because we've got my amigo Igor somewhere around here. Where you at? Hey, there he is, the man of the hour. How you doing,
Uh,
dude?
yeah, pretty good, mate. I s-
Well, I'm excited to chat with you. I'm also only have one job today, and I'm doing horrible at it already because we're a little bit late. So I'm just going to let you share your screen, and we'll get rocking on the next talk.
Absolutely.
So I'll be back in 20 minutes for some questions for you that come through in the chat. And for those that are wondering, you're planning on talking about graph retrieval, yeah?
That's right.
All right, cool. So if you want to share your screen, I'll throw it up on the screen, and then we can get going.
Yes. Let's see how do I share entire screen? There we go.
There it is.
Okay.
Here we go. I see
And
now, and we are boom. Excellent. So this is
awesome.
the this is the way you do it, where you start at the end, huh?
Yes.
I like your style.
Gotta keep it moving.
Yep.
All right.
All right.
Um,
Awesome.
all right then. Let's get moving. So, thanks for having me. I'm Yegor. Currently, at doing machine learning at Wise, and for having built up the Wise's machine learning team over the last 4 years and a bit. And I will talk to you today about graph retrieval. Because if you've been following the topic of retrieval, augmented generation at all, I'm sure you've heard the term graph rag. And no matter how big context windows get, still for the foreseeable future, it will be useful and helpful to first retrieve data that you think might be relevant and feed that to the LLM. And how do you define relevant? Of course, there is always vector search, be it sparse or dense, but the other nature, but it's a natural assumption that graphs are a nice way of thinking about relationships. Then things like, what else do we know about this person who is mentioned in the text snippet that I care about? Or what have they done? What are the things they're associated with? And so everybody's talking about using graphs for RAG, but they mean very different things by it. So the very term graph RAG, it can mean a specific approach that Microsoft open sourced some months ago, or it can be any kind of using RAG for retrieval. And what I'm trying to do here is give you a bit of a mental map and a Lego set of things you can do and components you can use to do retrieval with graphs. First of all, what are we even talking about here? What kind of graphs? How do I stuff the stuff I care about into graphs? The first case are the classical knowledge graphs. So you have entities, which can be, for example, people or microservices, and then Alice built service one, Bob also built service one or participated in building it. Bob maintains service two. So that kind of representation. So the graph vertices there are semantic entities like people or microservices or whatever it is that you care about, contracts. And the edges are their relationships. And then each entity must have a specific entity type, such as people or person or software or whatever it is. And the relationships have a type and a direction. And this definition is called an ontology, nice Greek word. And an ontology restricts what kind of entities you allow and what kind of things and what kind of relationships between them you allow. For example, you could have entities human and thing, and a human could own a thing, but not vice versa. And why is there a resurgence in knowledge graphs? Because they've been around forever. They've been probably around since before I was born. But the reason they are now resurgent is because LLMs make it really easy to generate them. And also, it looks like they might be useful for retrieval purposes, and people are trying to make them so. So how do I make me a knowledge graph? The biggest or the messiest part of making a knowledge graph is what ontology do you want to use? Where do you take it? The first one, which is all that there really was until LLMs happened, was you have to write down an ontology by hand. What are my entities? What are my relationships that I care about? And it still has its place because if you do this, there's far less that can go wrong. But the cons are it's a hassle. it's not clear, especially when you're just starting playing with these things, where do I get started? And it's always a question, do I have enough coverage? Does this ontology really cover all the bits I care about? Option two, for for somebody who has been reading and participating in the AI hype, let's just ask the LLM. And LLM knows what an ontology is, or at least sort of kinda. Let the LLM just write one. And that sounds nice. So you just throw each piece of text at an LLM and say, what are the entities in there? What are the relationships in there? Return that to me as a list of triplets of strings. It'll do so. The problem you'll run into then is that entity and relationship disambiguation. So the same logical entity will be referred to in slightly different ways in different text snippets. And once you've extracted it, it's much harder to determine that it is in fact the same entity. And you'll have to probably again go to LLMs or do some kind of fairly messy magic to determine that these three different strings actually refer to the same thing, to the same logical meaning. So the way I would recommend to do it is something in between, something kind of incremental. So you start with a limited human curated ontology. It could even be empty, or you could just have a go at the things you think you might care about. And then when you're using the LLM to extract entities from text and relationships, you give it the ontology you have and instruct it to use that whenever possible and only create new entities and relationships when the existing ones really, really don't fit. And what this does is do kind of implicit disambiguation. Because if there's a new relationship or entity in the text, which really kind of means the same thing as one you already have, it'll map it to that. Of course, like all applications, it's squishy and might not work, but it will mostly work. And since you'll be using it to extract text, which will feed to another LLM in the first place, so a bit of stochasticity won't kill you. And the nice thing about this approach also is the nice thing I generally love about LLM created specs is that they're human readable. So at the end of this result, you'll not only have the extracted entities and relationships, but the new ontology is still human readable. You can edit it and then treat it as fixed and rerun. Okay, the example flow is unaccountably missing, but it's basically, it was a diagram describing exactly that. And it'll be in the slides we have here. Practical tips. It's good to keep your ontology small. As always, the smaller you keep the universe you retrieve from, the easier you make it for the retrieval. One really cool idea, which I would recommend trying to steal in what you're doing, is specify in your LLM, instruct it to create an ontology by specifying which questions you want to answer, and only extracting entities and relationships which have some relevance to that. And actually, How.ai is one of the 2 or 3 companies which specialize in knowledge graphs, and they also have some open source ready-made schemas for specific domains. And there's also a nice link here to a blog post where I just like how they break down the practicalities of extracting one. All right, so much for knowledge graphs, but knowledge graphs in their last decade, if not last century. So the other thing we've been seeing a lot of lately is document-centered graphs, where basically you just break your text data into chunks, and then your graph just describes relationships between those chunks. And so the basic unit there is a text chunk, or the main property of each node is the associated text. It could be sections, it could be chat messages, it could be Jira issues, that kind of thing. Then what you usually do there is add a document level summary, and maybe even a hierarchy. So you have subsections in a section, then you have a section level summary, and then a document level summary of the section summaries, and so on. And it's actually been reported that adding a short summary of the document or of the section to the lower level nodes before embedding improves retrieval. And the edges are just these kind of things. Previous next relationships, relationships between summary nodes and things are summarizing, hyperlinks, and one that's really important in legal docs is cross-references between sections. So when one section refers to another, or if one section refers to a definition in another section, actually pulling that link and extract and inserting that bit as well really helps. And by the way, I was really shocked to find out that at least when I tried it, which was 2 months ago, for example, Llama Index's code for extracting Confluence pages and ingesting them was hardwired to discard hyperlinks. Not even, it wasn't like even a setting that's defaulted, it was hardwired to discard hyperlinks when ingesting Confluence. So when I watch the libraries you're using and watch what they're doing. Right. Then the next thing is hybrid graphs, because there is no reason why you should stick to just one of the above. So what you would really want to do is to combine both graph types in one store, and then you link from the document graph nodes to the entities they reference. And then you have one nice big graph with everything in them. And then if you're using a knowledge graph database, then those new nodes can just look like new kind of entity types and new kind of relationships to that graph database. And then what you'll typically also do, just like you had summary nodes for references, for sections and documents in the document-centered graph, you'd also want to do some kind of derived nodes in a mixed graph. So one thing, for example, that Microsoft's GraphRag does is you do text summaries for the knowledge graph style entities, and then you do clustering on the graph, and then you do knowledge summaries on the clusters, which GraphRag calls communities. And those can be hierarchical, like any clusters, and so on and so forth. One thing that I would really like to mention here briefly is keywords, because keywords is kind of a special thing, which is important, but they don't really map neatly to anything I discussed before. You can auto-extract them with something like keybird, and then can still try disambiguating them, for example, or you do incremental extraction like we did for ontologies above. But what are they? One way to do it, which is what is my understanding of how AstroDB does it, is you treat them similar to entities in a knowledge graph. So that they're just separate nodes, essentially, that are linked to documents that contain them. And it's, you can do it. It's a reasonable approach. And well, of course, what you're looking for is different documents which refer to the same, which contain the same keywords. But what I would rather do instead is to treat keyword extraction as an extreme form of parsing, and then apply some old school algorithm like TF-IDF or its newer successor BM25 for extraction, because then you can still match docs by keyword overlap, but less frequent keywords get upweighted. But that's just things to play with. Another thing to be aware of is, are your relationships stable over time? Because if they're not, then the relationships in the graph must represent this. And here is a link to a nice open source repo which claims to handle that well. I haven't used it myself, so if you try using it, I'd love to hear back from you. The other thing of time-dependent information is that the user interaction with whatever tool you're building and the things it produces can themselves be added to the graph for future reference. Though, of course, it's wise to flag them so they don't end up, so that erroneous summaries end up contaminating your original store. Right. So now suppose you've built this wonderful, wonderful graph with all these things in there. How do you query it? And here is where the fun starts, and the fuzziness really starts. Because all the things I've described are, so far in building a graph, they're like very non-controversial. Like all these things, it's clearly understood how to do them. I think all of them pretty much are a good idea if you can be bothered for your use case. But for querying graph, there is just a lot of different ways, and their experimentation is called for. because there is no like single known good way of doing it. First one is to use Cipher, which is the most common language for querying knowledge graphs, though of course not the only one. And then, because Cipher has also been around for a while, you can just ask an LLM to generate a Cipher query for you and run it against the graph database. It will retrieve something and give the something back to the LLM. And of course, you'll need to have a validation feedback loop just in case your LLM generates an invalid query or a query that returns no results. But you can do this. And this you can do also with pure knowledge graphs. Something that I have a preference for, though I haven't tried extensively using it. So ask me again in a month and a half whether I still think the same thing, is that you do two-stage retrieval. First, you use good old vector retrieval to look for individual nodes in that graph. All the ones, be they derived nodes or primary nodes, whatever you have in there. And then you can have actually several kinds of vector retrieval, right? You can do embeddings, you can do full text search, or you can even do full text sparse retrieval by keywords, as I described. And then you merge them via reciprocal rank fusion, for example. And then you use those as starting points to apply a graph algo. So then you have those initial nodes, and then you in-hop neighborhood, or customized page rank, or your favorite graph algo to look at for important points in the neighborhood of them. And then subsample them via maximum marginal relevance, for example, and that's the result you're getting. An important trick here is that for running graph algos, you might want to use not your original graph, but some kind of a derived graph. For example, your original graph might contain a lot of intermediate links. So a chat message might link a chat message might link to the profile to the Slack profile of the person, which might link to the person entity, which will again link to the Confluence profile, which will link to a Confluence snippet by that person. And then you might want to just say this Confluence snippet and this chat message were authored by the same person and treat this as a direct connection and run PageRank on that. Multi-step retrieval is a general pattern, not just for GraphRag, which is useful, which is you query once, you ask the LLM, do you have enough, or do you want to know some more, given what you've just learned, and then you query again and again, either just in a loop, or you can even build a whole recursive tree of questions. And here are some summaries of overviews of different patterns. And it's really a field where there's just no consensus of the right way of doing it, so you have to look around and see. And the ones I presented are just my favorite ones. Right, and just to put some controversy into it, because the Metro has promised me that the audience is my fellow nerds, and what would be a nerd discussion without some flame wars about the stack you want to use. So these are my personal preferences. I haven't tried everything out there, of course, but for embedded, Kuzo and TanTV have played with, and they worked fine. And for running it, them as separate services, I think pgvector works fine in Postgres Stack Search for vector retrieval. And I'll be actually looking very closely into TypeDB for graph-related stuff. And of course, I recommend Motley Crew AI, which is a framework for agents that I co-authored. And that's the long and short of it. So hopefully now you have a bit of a mental map of what's involved in GraphRag. And if you want to discuss some more, please ping me on LinkedIn or on email.
Awesome. That is great. So questions coming through hot in the chat, and I've got my own because I want to know if you have tried GraphRag without ontology before, and if so, what was your experience?
I have not. What I have tried, well, no, I'm lying here. So what I've done graph retrieval on code bases. Because you don't need an ontology to construct a graph. You're right. So it's very natural to map entities in a code base. No, but then again, I was using in a code base. I was using like syntactic parsing, and so code syntax is an implicit ontology. So actually, there was an ontology underlying that.
Huh.
So I have not. But again, if you just want to stick between without an ontology, you would just stick to keywords and lexical graphs. Sure, you can do it, and it's I guess the advantage there is that it's much less effort to construct.
Yeah. Yeah, because I've heard of some people doing it, and they swear by it, kind of thing. So, but there's more questions coming through in the chat. How scalable is it to the user, the vector search plus graph query approach? How scalable is this approach?
Well, the vector search you need to do for any other graph for any other RAG anyway. And the graph part is fast because it's all symbolic. You don't need to call it LM for the graph search. You just want to a graph algos on specialized graph databases is actually pretty fast.
Yeah. Okay, cool. And what about well, a lot of people are asking for you to share the slides and share all the links that you had in the slides because they couldn't take a picture quick enough when you were going through
Of course. No, I've uploaded I've uploaded the presentation to your drive, and
Excellent.
I've posted on my LinkedIn as well. And
Excellent.
also, since Demetrius, you promised me that the audience will be fellow nerds, so I went as fast as I like speakers to go, and very happy to keep on discussing on LinkedIn or over email.
Cool. Yeah, there's like 3 or 4 questions in here in the chat. One is, does graph rag improve the performance as opposed to normal rag?
I guess it depends on the questions you're asking. So certainly when you're dealing with code bases, then knowing the signatures of the thing you're calling in the code snippet you care about helps very much. In legal docs, having the definitions of the terms that you're using or the sections that are being referred to in the snippet you retrieved helps a lot. In other contexts, less so. So I don't think there is a graph rag right now is very much this evolving thing where I don't think there are real best practices. It's just
That's
gut
a
feel. Do you need
great
it?
answer. Yeah. Context specific. Do you have the LLM explicitly make changes to the ontology and then as a separate step have the LLM populate using the enhanced ontology?
Well, as usual, I recommend doing the simplest thing that works.
Yeah.
If you can write down your ontology up front, great. If not, I would recommend doing it incrementally, as I described. So you start with the sum ontology, and then you feed it like one document at a time or a couple of documents at a time, and have the LLM extend the ontology with each whenever it finds it's not enough. And this way, you don't have to reprocess everything from scratch this way also implicitly you disambiguate because the LM generally, if you prompt it right, the LM won't add things which are already there in the ontology. So for me, that's my favorite way of deriving LMs by ontologies incrementally like that.
Last one for you. Have you seen any common patterns on when we should decide to go for knowledge graph rag versus just regular rag?
I think it's always like start with dumb hybrid vector search,
Okay.
and then look at the ways in which it's failing to retrieve the things you think it should for the questions you care about, and then think, is it about concepts? Is it about just related text? And based on which things you would like it to retrieve, that's the kind of graph you need to build.
Perfect. Well, dude, as always, it is a pleasure. And for anybody that is wanting to ask more questions of you, you're on LinkedIn, you're sharing the slides with us on LinkedIn and also in the recording. So I really appreciate that. And I guess that's it. We're going to keep it moving because, as usual, I'm late and we got to go.
Absolutely. Thanks for having me.
All right, man. See ya. Now, let's get rocking and rolling. But before we do, there was this guy that was jumping in here. I don't know what the hell's going on here. Hold on a second. Bonjour, my name is Jacques, and I've never met a version of myself I did not like.
L'énergie. Oh oui. Le petit café.
J'avais gravé ton nom sur un arbre, sur une table. J'en oubliais mes leçons, mes poésies, mes fables. Pour l'absence.
This stick,
Ce moment-là, je ne sais pas. Je crois que c'est
I
mes
think I'm using it now.
Je crois que c'est mes ne
my
suffit
brain.
pas.
It's my new paintbrush. Look at this stick. Oh, now I am Harry Potter. Maximus.
Mwah! What the hell was that? All right, y'all. We got the next. We got the next talk coming up. Mohan, where are you at? I'm bringing you on the stage right now. Yeah, there he is. How you doing, dude?
I'm doing well. Can you hear me okay?
Yeah, hear you loud and clear.
Perfect.
I'm going to let you share your screen and we are going to get to the talk of yours right now. I'm very excited. We're going to be bridging the gap between model development and AI infrastructure. Right on. I see your screen here, so let's rock and roll, man.
Perfect. Hey, thank you all. Fantastic opportunity and good to see you again, Dimitrios. It's fantastic to be back again. So we thought we would want to talk about a topic that is not just close to our heart, but to a large number of providers in the market and enterprises. And this will be an interesting conversation. And I've kind of kept it somewhat at a higher level. Hopefully, this will be, given the audience here, I think this may be very intriguing for some of them. So let's talk about that. So a little bit about me, in case I love chatting with people on LinkedIn, Twitter, email, wherever you want, wherever you are. We also blog extensively. So a little bit about me, if you want to stay in touch and chat with me. I'm based on Pacific time in the San Francisco Bay Area. If you're at local meetups and other things, or if you're going to be at NVIDIA's GTC next week, look me up. I'll be hanging around the RAFE booth. Okay, so let's start with a little bit of a view of the landscape. And then hopefully this will help you reset your thinking a little bit, right? So if you look at the landscape, and you can kind of broadly put the users in two buckets. There are trainers, as in these are the people who create the foundational models and all that. And then there are tuners and inferencers. Right? So these are people who use the foundational models, right? As an example. So if you look at the number of companies, if you look at number of companies as the dimension, there are very few trainers, but there are thousands, tens of thousands, maybe even millions of organizations who are going to be tuners and inferencers, right? Completely different kind of a logarithmic scale for tuners and inferencers. But if you flip the logic and you think about scale of AI infrastructure, and what do I mean by that? What I mean is, well, we just look at GPU count as an example, number of GPUs. The entire story is flipped on its head, right? The trainers today have crazy number of GPUs, and the tuners and inferencers are what the industry terms today as GPU poor. Well, I'm GPU poor too, for example, right? I'm not a trainer. I struggle to find GPUs at the right time and the tooling at the right time to do my tuning and inferencing. This is the state of the market today, right? Now you may say, hey, Mohan, this all sounds good, but let's see some numbers. Let's see some numbers here, right? So when Meta trained and launched Llama 3.1, which is, for all practical purposes, history now, right? They claim they use about 16,000 H100 GPUs. Well, that's a big number. And if you've been on Twitter and you've been watching Elon Musk's posts about X.AI, you know Grok 3, apparently they're using 100,000 H100s. And it's rumored that OpenAI has 25,000 A100s when they launched GPT-4. GPT-4 also is old, it's history, right? And look at how the numbers are projected to change. By the end of 2025, Meta expects to have 600,000 H100s. And here we are, like most of us are looking for, like, can I get one H100 to do my job? So, the trainers, I think the point I'm trying to make is these guys are operating at a different scale, but you can probably count them in two hands. There's only that many of them, right? These guys are going to have the lion's share of AI infrastructure. So you may be now thinking, hey, how is this going to help me? I'm not at any of these companies. I'm not a trainer in the sense that I'm not creating a foundation model, perhaps. What am I doing at this presentation? Well, the conversation is not about these guys. The conversation is about the rest of us, right? But I just wanted to make sure that we talk about how these guys operate at a different scale, so we kind of have some relative sense of numbers that we're talking about. Okay, so now let's pivot to folks like you and me and hundreds of other people who are trying to either develop a fine-tuned model or develop my own statistical model or do some inferencing. What are my challenges, right? And everyone here in this meeting probably has encountered these problems, right? I need a GPU for my GenAI chatbot app in my enterprise, and by the time I put in a ticket to enterprise IT and I get access to it, oh my God, I'm frustrated. So I just go to the nearest GPU cloud and I put in my credit card and I get access to what I need. Right? And enterprise not happy, and you're not happy that the IT team is able to give you what you need. This is a story of a lot of our lives today, right? And if you go talk to enterprise IT, they talk about, oh my God, if I give everyone a GPU, then it's going to cost us a lot of money. And what about idling GPUs? Because we do make a mistake. Like, think about how many times you spin up something and you forget to turn it off. And if it's a GPU, man, your numbers are going to add up like crazy, right? So these are the challenges that people are facing. The folks on the top, folks like you and me, who need access to GPUs, and not just GPUs, but sometimes also things like compute, things like storage, things like high-end memory, things like access to data. We just don't get it when we need it, right? And there's always this tension between folks like us and in many cases IT. So how do we solve this? So in summary, these are the 5 core issues that organizations struggle with and users struggle with, right? I don't get access to what I need quickly. I want to experiment. Again, how many of you were like desperate to try out DeepSeek when it launched a few weeks back, right? You probably tried it on your own dime outside the company's infrastructure because you were just curious. You had to experiment. You probably didn't get access to it quickly enough, right? So these are the 5 big challenges that we see again and again and again. Everyone is struggling with it, and there's got to be a solution to this problem, right? It cannot. AI will. The growth with AI and adoption with AI will kind of be cramped unless these problems are solved somehow, right? So how do we bridge these gaps, right? The users and the AI infrastructure and this IT in between who today is not able to provide that bridge. They want to build that bridge, desperately build that bridge. So what we believe is needed is you need a platform as a service, as a critical middleware that acts as that bridge between the users and IT-owned AI infrastructure. The IT-owned AI infrastructure could be GPUs, could be VMs, could be Kubernetes clusters, could be data. Because as users on the left, I just want to fine-tune. I just want to build my model. I want to use my Jupyter notebook. Why do I have to go learn Kubernetes? Why do I have to go learn about containers? Or what do I have to learn about cloud? I mean, is it really needed? Let me do my job, right? It's a fast-moving world. So what do we do now, right? So just to kind of summarize, right? The gap here is you as users want to use one of these. I think most of you here are probably extremely familiar with these tools on the top. Some of you might be using Ray. Some of you might be using Kubeflow as an MLOps platform. Some of you might be using MLflow. And then there's like hundreds of these applications on top. And some of you might be building your apps on top of this, right? Not using these platforms, but building your own apps. And right at the bottom, you have accelerated computing infrastructure. And the company says, well, we got some GPUs, right? Maybe 50 GPUs. And what you need in middle is this pass. What does that pass do really, right? It will help with two problems: orchestration and governance, and consumption and monetization. And you might be thinking, what the hell does that mean really, right? What this really means is this, right? As a user, you want to be able to like literally click a button and get the right kind of infrastructure instantly. Most of you probably don't have that today. It'd be nice if you did. And your kind of infrastructure, some of you may say, hey, I need a VM with a GPU in it. Another person on the call here might say, hey, can I get a cluster with some GPUs on it? Another person is going to say, hey, I kind of need bare metal servers for my job. Another one's going to say, you know what? Hey, we've been doing this thing for 15, 20 years. We come from the HPC land. We kind of need Slurm with GPUs on it. How is IT going to manage all these things? I mean, think about those poor souls, right? When they're going to struggle, right? Like managing all these various asks that everyone has. And they have a limited pool of resources below. So they need to make sure that they operate this efficiently. So what would that look like? The answer for this is you got to centralize. There's no choice, right? Like, and this is something that we kind of been working with a lot of large enterprises, and this is the answer that they have settled onto. Well, what does this mean? If I have, let's take an example, a large hedge fund that we've been working with, they said, hey, look, we have this, 100 GPUs, right? And we have, 50, 60 data scientists, and it's a hedge fund. So they live and die off their ML models, right? When the ML models are right, what are making the decision on how to trade, right? And what to trade on. And in a volatile market like what it is right now, these models and their accuracy can mean the difference between profit or loss, right? So this is, in this landscape, it is their backbone, the quality of their ML models. Now, if the data scientists don't have access to the GPUs when they need it, they're not going to be producing models. Business is toast, right? So that's the situation they found themselves in. And the answer for them was, hey, let me centralize the GPUs. And if there are idling GPUs, I can reclaim and put it back in a central pool and give it to someone else who needs it. When someone who needs it, I'll give it to them instantly. I'll give it to them in a form factor that they care about, right? So that's the ideal experience that I think organizations are settling on. Now, let's see what this could look like, right? And some of you might be thinking, hey, all kind of sounds nice. Well, let's what would this look like as a user? So we're going to look at two things. We're going to look at, if I am a data scientist or an ML researcher, what is the ideal experience? What could it be like? What should it be like, right? So we'll see that. The second part we'll see is, well, somehow that experience was created. How was it done? Like, and Dimitrios had the nice Harry Potter video just before this. Is IT going to wave a wand and deliver this experience, or how are they going to design it? How are they going to deliver it? Well, that's an important aspect as well. So there's a balance between these two that delivers the whole solution for the vast majority of us. Now, if you are one of those lucky companies that has 100,000 GPUs, like one of the foundation model, the trainers, as I called it, I think you probably have a dedicated team whose only job is to deliver this massive Colossus kind of a cluster for your job. The rest of us don't have anything like that. So let's see what this would look like, right? Now, what I'm going to do is first start with the stuff on the left, right? The end user experience. I'm going to pivot to a quick demo here, right? So, and I'm sharing my screen, so you should be able to see it. And Dimitrios, if you could just let me know if this is not visible. So as a user, I log in, I get my own portal, right? So let's say Dimitrios and I are data scientists of this company, right? I log in and I'm given a shopping cart, right? I'm given a shopping cart. And in the shopping cart, I can ask for all kind of compute. I can ask for notebooks. I can ask for a lot of these things that somehow magically has been created. Now, if you walk to your local store,
bigger? Sorry, Mohan. Sorry.
Yes.
Can you make it a little bigger?
Yeah. I'm on
Awesome.
extreme magnification, so hopefully it's not going to mangle the experience. But let's try it. So
even that's great.
I'm a data. Is it looking okay now?
Yeah. If you can go bigger, then awesome. But if that's the best we got, I'm happy with it.
Okay, let's try it. It's probably going to mangle
looking
the look and feel, but let's try it, right? Apologies, I'm on an external monitor here. So as a user, I'm a data scientist. I just want stuff, right? And I want it quickly and instantly. So now, just like you guys go into your local grocery store, and you go there and you know where to look for apples, oranges, sugar, coffee. You just go to the menu, you go to the aisle, you pick what you want, you say, hey, I want to pay for it, and you get to use it. Why can't that kind of an experience be possible for data scientists and ML researchers in a company? Why does it have to be so complicated? So here's what you're seeing. So what you're seeing here is me as a user. I'm given a menu of options. Right? These are standardized options that the company has provided me. Right? Someone in IT has said, "Hey, these are this is what is in our shopping cart. You go do whatever you want. You can use them." So if I go and say, "Hey, I want this medium instance with 8 CPUs, 16 gig memory, and 2 GPUs," all I have to do is say, "Yeah, I want that." Give it a name and say go. Right? So I just give it a name and say go. And in a few seconds, you'll have an instance like this that has been launched. And the same thing with the notebook. I want a Jupyter notebook, no problems. Just, something has been curated for you. You give it a name, you deploy it on a particular instance that you have, and then you choose among the various profiles that exist. All this has been curated. So this actually has been a lifesaver for a bunch of users, because we've seen data scientists struggle with, hey, I don't have the right. It works for my colleague, it's not working for me. Why? Well, I had the wrong version of Python, the wrong version of PyTorch. So it's working for him and not for me. And we've seen people waste a week trying to figure that out. Similarly here, what about other things? Well, compute and notebook are easy peasy, right? What's a big deal, right? What is interesting is what I'm going to show you, right? What end users should be able to get is any AI ML platform or application available at one click away, right? So for example, in the last 3 weeks, I'm going to talk a little bit about everyone's kind of been hot and bothered about DeepSeek. A lot of people mostly want to be able to try it and see, is it real? Is it not? Can I quickly try it? Can I see if it'll change my existing platform dramatically? Should we be using it? How do I form an opinion? All of us experiment. And now, what many of our customers have been doing is they've been like asking for cards like these, where they say, hey, if I give this to my users, anyone should be able to click a button and get access to it. So if I want to try DeepSeek, I just have to click something, give it a name, and say go. That's it. And the whole thing will come up, and the IT is able to give me a curated experience for everything I need, and they were able to get this going in about 15 to 20 minutes for the users. Same thing with other things. I want to try NVIDIA NIMs. Well, if I do it the traditional way, I got to be a Kubernetes expert. I got to be a Helm expert. I got to understand how to debug it, troubleshoot it. No data scientist or researcher cares about all that. They have not time for all of that. So what if it's one click away from me and I can try it? Same thing with SageMaker, same thing with Slurm. All these things, you can package any app. This is the experience that I think is ideal for users, end users who can focus on their job, right? They don't want to go learn infrastructure stuff. They get to use it. So now let's pivot into the second part, which is actually the more interesting part, which is how did this experience get designed, right? There was something done where this was done, right? So let's go look at that. I'm going to make this bigger too. So there's what we want to offer is a studio for IT. What IT is going to do is they're going to publish these profiles, right? They're going to say, hey, medium in my case means this, right? And they will design the SKU. Just like there's a store, somebody in the store is designing, hey, I want to have these kind of apples, this kind of sugar, this kind of stuff in the store. Someone is designing these and saying, what can you do and cannot do? And all the complexity is abstracted away from the end users to provide that curated experience. Same thing with services. Like if you want to have DeepSeek, the example you saw was this, right? We did another one where we said, hey, this company wants to do some classification of ships as an AI ML job. It should be a button click away, all right? So this is kind of what I think most organizations should be looking at, which is deliver a stellar experience for a user where they are not bogged down by complexities and nuances of various kinds of AI infrastructure. It should be like your laptop. You open it, press a button, log in, use it, right? That's what has to be given to folks like us so that we can do our jobs faster. We are now at an interesting point in terms of the AI ML flywheel, at least in my point of view. It's accelerating. It's accelerating to a point where the difference between success and failure is going to be how fast can you iterate, right? And that is where you don't need unwanted baggage, right? So we need to find a way to shed it. And that's kind of what we're focused on. So what you saw here was essentially something like this. From an architecture perspective, this is what it looked like. There was a shared Kubernetes cluster. The company had set up one massive cluster with, I don't know, 50, 60 GPUs, right? And you had 4 or 5 people hanging off the same cluster with their own tenants, right? So this data scientist is doing something with Jupyter on this compute instance, and they asked for 1 GPU. This ML researcher said, hey, I want to do Jupyter, but I want to do some training on Ray, and I'm operating with 2 GPUs that was allocated out of this pool. The GenAI developer said, hey, I want to use DeepSeek and I want to do some, or Llama, and I want to run some massive inferencing thing. Well, you need a lot of GPUs for that. So something was given out of this pool to this guy, 4 GPUs in this case. And when these guys finish the job, this will go back to the pool. The next guy can get it. This is kind of what you saw in the demo. Extremely efficient for the IT and operations. So nobody here is going to be GPU poor, right? Everybody gets a fair share, right? Everybody gets access to stuff. They do their job efficiently. They don't know anything about Kubernetes. They don't need to know anything about containers. They focus on their models. They live in their Jupyter notebooks, right? They live in Python code. That is where I think the market has to be, so that folks like data scientists, researchers, and then Gen AI developers can actually get the flywheel moving faster, right? So that, in a nutshell, is kind of what we think the market needs. In a nutshell, to bridge the gap between the low-level AI infrastructure to what the people need on top. What they really, really need is self-service consumption and usage of GPUs, right? No more waiting for, like allocations that take 2 weeks, a week, etc. Whatever AI app you want to try has to be templatized and has to be one click away for me to try things, so I can get it tried quickly and move on. Everything has to be on shared infrastructure. No company can afford dedicated stuff. So multi-tenancy is a big deal. Like the example we saw there, where we had multiple people living on the same unified shared AI infrastructure. So these are the 3 simple things that I would encourage you to factor in, and make sure the end user experience is stellar, right? The end users really, really matter here. Now, if you're interested in learning a little bit more about us, we blog extensively, at least 2-3 blogs a week on some topic related to GPUs, AI, ML, data scientists, etc. Right? Mostly around AI infrastructure orchestration. So we blog here. Please go have a look. Right? We do have extensive documentation and getting started guides. And then, of course, welcome to sign up for a free org. You know, if you want to experience what you just saw, give it a spin. So that's all I had, Dimitrios. I hope I stayed on time. If there's anything else, I'm happy to take any questions and love to interact with people on LinkedIn, Twitter, etc. Thank you.
100%. Actually, could you leave that last slide up with the that's all right.
Sorry.
The one with all the links, because the blog is highly recommended, and I want to make sure that in case people enjoy infra, they get to see that and check it out. Let me see if I can bring that back on stage. All right, cool. So, and might need to be a little bigger, but we'll drop it in the chat too. There's a few questions coming through from me. I'm wondering, how do you get new tools implemented into Rafa? Is it on your side or is it on my side? Do I need to, let's say that I want to use a specific tool and plug it in with you guys. How would that work?
Yeah, great question. So this is a process that happens in every company. There's usually 1 or 2 data scientists who go to a conference and learn about a new tool. Like, let's take Ray as an example. 3 years ago, probably not many people knew about Ray, right? It's a newer framework. It's a cool framework. It's hot. It's amazing. So what people would do is they'd say, hey, we really tried it. We liked it. Can you encapsulate it? And the work here is done typically using the past studio that I showed, and is done by IT. It takes about 15 to 20 minutes to templatize some standard configuration, test it, and then open it up to everybody, right? Every app that I was showing there is about a 15, 20-minute job. Essentially, think of the analogy that I used. The work here is essentially say, hey, how am I going to make it available in that store? Which aisle am I going to put it in? Yeah. What price point am I going to put on it? How am I going to bill it? Some kind of a QR code or barcode or something, right? That's pretty much all that is needed. And the rest of it is just extremely straightforward. 15 to 30 minutes work stops to onboard a new tool. Now, the good thing is, you can go from one guy who learned about it to everybody in the company being able to use it in a matter of like days. I think that's the value.
Nice. Okay, so the next question that I had for you was coming through in the chat. In shared infra, we found noisy neighbor problems resulting in QoS issues. Yes. Have you taken care of that problem in your GPU pass?
Yes.
I guess is how you pronounce it.
That's right. That's exactly right. Noisy neighbor problem can be a huge challenge. And we have a bunch of controls in place to, I would not say eliminate it, but minimize it. There's always going to be some dimension that can cause challenges, but we minimize it to a point where it's a non-issue for 99% of the use cases.
Okay, excellent. And the part on like using different tools inside of it, that does it not matter if it is open source or closed source? It's the same kind of process for each?
Yeah, great question. Let's take an example. If you look at these two guys, Data Robot and Data IQ, and there's a reason why I took this particular set of examples. You look at the examples on top, many of these are open source, but Data Robot and Data IQ are not. They are commercial products, right? So for some of these guys, we have worked with them, or we continue to work with them behind the scenes with commercial products and bring them in, right? We make this turnkey with those commercial providers because there's enough number of people who care about it, right? If you guys see anything here that is missing, we have a catalog of these integrations with third parties where with commercial vendors, we have to make it whole for them, right? With open source, is much easier, of course. We can curate it, or customers can curate it themselves.
So I've heard this a few times, which is the best part about a managed service is that it's a managed service. And the worst part about a managed service, it's a managed service, right? So you want to be able to give knobs and whistles to folks if they want to go deeper. How do you look at that, especially like you being the product guy? And I'm sure that it's not the first time that you've heard that.
Yeah, it's actually an amazing question. And whoever asked this question, I guess, has lived this before. So let's spend this 30 seconds on it, right? So the question is more around abstraction. Sometimes can be a royal pain and can be a negative if done badly, right? Which is why, if you notice here, there's two layers here, right? If the abstraction with the AI/ML tool on top is too tight and too closed, the user may come back and say, well, this is not of any use to me, right? I have to do everything all over again. So it is possible for the IT teams to perhaps swing the pendulum completely to the other side. It is completely possible because abstraction can be too tight, too closed, and all of that. This is why we have like gradient controls. So the other option is the end users sometimes decide, hey, look, whatever IT is given me is too tight, too abstracted away. I'll go consume the lower level stuff. Like they may land up saying, hey, I'll get, I'll use a Kubernetes cluster or a VM that the GPU PaaS gave me, and I'll install the tool myself. In fact, that's how people experiment and provide feedback to IT. Because how does IT know whether they drew the line at the right place? Sometimes they make mistakes. So the end users have an opportunity to give feedback and say, hey, look, can you please loosen up the abstraction a little more? Give us a few more knobs. And it's an iterative process to get there.
Yeah. That's always the fun part. So Mohan, this has been awesome, man. I really appreciate you coming on here and sharing more. And we will be in touch, I guess. You're on LinkedIn, so if anyone wants to jump in there and continue the conversation, they will.
Absolutely. And I'll upload these slides on the usual place, and looking forward to interacting with people. And thank you again for the opportunity. Very cool. Yeah. And a huge shout out to Rafai for helping sponsor this event. You guys are really making it happen. I am very thankful for that. So I want to just call that out again. It's big thanks for your support. Thank you, Dimitrios. All right. We'll see you later. And now we're going to keep it moving because there was supposed to be a break, but you guessed it, I'm behind on time. And so we don't have a break, but we do have this French guy. He dropped in again. What is going on here? I gotta give him a moment before we get to our next talks.
petit café, I smell it. Oh, petit café. Très joli.
Alors, qui dit études dit travail, fatigue dit réveil, encore sur de la veille, alors on sort pour oublier tous les problèmes. Alors on danse, alors on danse.
Oh, les petits cafés. Oh, oh, sentiment fantastique.
What the hell was that? How are we going to follow something like that? I hope you all are enjoying yourselves. We're trying to keep it light around here. And next up, we've got my good friend Rasa and Brianna coming on the stage. I'm so excited for this chat. Let me bring them on the stage so we can say hi. What's up? Rasa, how
Hey,
you doing?
Demetrius, good to see you. And hello to the MLOps community.
Yes. So you all have got a talk for us all about eval-driven development. I'm very excited for this because, as I like to talk amongst friends, we all kind of know benchmarks are bullshit, and hopefully you can tell us a better way to do it.
Absolutely. Excited.
So I see there's this here. I'll let you guys get rocking and we'll keep it moving. I'll be back in 20 minutes with questions.
Sounds good. Well, hello to everyone who's online, and thanks very much, Demetrius. So Brianna and I are going to be chatting today a little bit about eval-driven development for AI. So I'm the CEO and co-founder of Human Loop, and I'll tell you a little bit about myself in a moment. And Brianna is the head of data science at Eval-driven, and I'm going to try and give you a little bit of the lessons that we've learned as the eval platform for enterprises at Human Loop. And then Brianna will sort of jump in midway and take over and talk about sort of doing it in practice, actually building a real world product at enormous scale. So maybe just like a little bit about me to start with, to give the context. Why should you be listening to my opinions about how to build AI products at all? So I'm the CEO and co-founder of Human Loop. We're the LM eval platform for enterprises. So we're helping companies who are trying to build reliable AI agents or products to get them into production and to make them good enough and reliable enough for their customers at scale. And before that, I did a PhD in probabilistic deep learning. I worked at Google and Monolith for a while. But critically, over the last 2 years, I've been working really closely with some of the leading companies who are building AI agents and products on the frontier. So Eval-driven being one of them, but also Duolingo and Gusto and Vanta and Vendor and Macmillan and many others. And so what I'm trying to do with the talk today is to summarize some of the lessons that we've learned from working really closely with those customers about what the best teams do to build these amazing AI products, and to share some of those best practices. And so that's hopefully the core of it. So what I would like you to be able to take away is why evals is so important, how to do it well in practice, and also kind of what the lessons of the best teams are. And it's really not that complicated. Something that we've seen universally through Human Loop that all of the best AI teams do is 3 things. And the first one is unsurprising, given the title of the talk, is they put evaluation at the center of development. And most of what I talk about will be focused on why that's so important. But there's 2 other things that they do that I think are really critical as well. And Brianna will speak to concrete examples in a moment. But one is they spend a lot of time looking at their data. And I think people who are coming from a machine learning background, from a data science background, that won't be such a crazy idea. It's almost cliche at this point. But what's happened with LMs and Gen AI is I think there's a lot of developers who are coming to AI for the first time from a more traditional software engineering background. And they maybe underestimate how much alpha and benefit there is in spending time looking at the traces of your AI agents, of the logs of what's happened, of how people are interacting with the system, and just building a qualitative sense of where are the failure cases, where are things strong. And so anything you can do to reduce the friction and provide observability tools that work well to your team tends to be extremely high value. And the last thing that I think is particularly true for GenAI, even more so than any machine learning that come before, is that the role of domain experts throughout the process has become even more important. And that's partly because the way that these LLM apps are built relies very heavily on prompt engineering, is often very subjective to evaluate. And so having the right domain experts as part of the process is often the difference between building a product that's okay and building one that users like really, really love. And we've seen pretty consistently that the teams who do these three things tend to produce better AI products that get more success than the ones that don't. Okay, so why are evals so important? Why does Human Loop focus on this so much? Well, fundamentally, LLM agents and applications aren't just the model, right? They're complicated systems. You have the core LLM, but then you also have, if you're building RAG systems, the data source and the way you chunk the documents. If you're building agents, you have the choice of all the different tools. You have the actual prompt template. Maybe there's some control flow that's kind of governing how the agent works. It's not crazy complicated, but there are enough design decisions that if you don't have a good way of measuring performance, it becomes very hard to actually make the system robust or to improve it over time, right? You're trying to choose like, which of the models should I use? Do I use OpenAI? Do I use Claude? Do I use something open source? What should the prompt template be? Like, what's the right way to construct the context? What are my tool definitions? And because every time you run these systems, you get different answers, because it's subjective to evaluate, without good measurement in place, without good evaluation, it's very easy as a team to spin your wheels and not make any progress on actually improving these things. And the other reason why evals is so important is that I think with Gen AI development, even more so than normal software development, machine learning development, the speed of iteration is really what determines your success. And when you're building software in general, you'll often have a very clearly defined spec and you'll work against that. Whereas I think with Gen AI applications, the teams who do best build an end-to-end version, an MVP version of their product very quickly, and then they iterate on all of those components that we saw in that diagram before. They iterate on the prompt templates, on the tool definitions, on how they do their chunking for RAG. And after each iteration, you need to get quantitative feedback on, did I actually improve this or not, if you're going to actually improve the system. And so giving you the right tools to be able to iterate quickly and get feedback in a development loop that involves evals is kind of the core of what we've been trying to help teams do and what we think is critical to success. And so we call it eval-driven development. And evaluation really shows up at three different places when building these LLM products, right? So initially, when you're first starting off, it's probably just intuitive, interactive-based evaluation. The first thing you're going to do is create a prompt template, create a first version of the system, and just validate as the domain expert looking at outputs, is this good enough? Does it work? But you very quickly want to move from that sort of vibe-based analysis to something much more concrete, which is sort of offline batch-based evaluation, where you're going to have a data set, you're going to have a systematic set of evaluators, and for every major change you're making to the system, you want to be able to get quantitative feedback. And then finally, once you're in production, you still want to be monitoring the same types of metrics that you set up during development in production. And I guess what's different about, so that's the process that we think about with eval-driven development, is that you make a change to the system with some hypothesis about how you're going to improve it, and then you get quantitative feedback from these evaluators on whether it worked, and you repeat that process very quickly until you've got the system to be sufficiently good to deploy in production, and then post-deployment, you continue monitoring it. Evals fundamentally are just this, are kind of analogous to unit and integration tests, but for stochastic software. And similarly to traditional testing, where you would have unit tests that you'd run very frequently and that are cheap to run, and then maybe integration tests and end-to-end tests are more complex and maybe not run quite as much. There's kind of three levels of evaluation that you have for LLM models. So the simplest is you have code-based evaluators that are checking things like valid JSON, length. They're cheap to run, they're very fast. LLM-based judges that can be run more frequently and can be done at scale, but maybe are not quite as good as human. And then the kind of equivalent to end-to-end tests would be human feedback. And so the teams we work with, almost all of them have all of these three types of evaluators. They have simple code-based assertions, they gather human feedback, and then they use that to align LLMs as judges to actually scale that evaluation in production. And I have some examples here, but I'm going to jump past them to just summarize the kind of lessons that we've learned so that I can hand over to Brianna to talk about what this looks like in practice. So if I was to like summarize sort of the best practices that we've seen from teams building with AI, I think the most important one, the sort of number one at the top, would be to have good evals in place from the start and iterate against them. It would be to look at your data a lot and make it easy to do so. So I think a lot of teams log everything, but it's not necessarily something that's accessible to their PMs, to their data scientists, the engineers who are actually building the product. So making those logs very close to where prompt engineering is happening, to where the actual development work is happening. Build the first version of the system as quickly as possible and then iterate alongside evals. Make sure that you have simple code assertions first, and then layer on LLM as judge and human feedback afterwards. And as far as possible, you want to be using the human feedback to align those LLMs as judges rather than relying on the human feedback, because that's much more scalable. And if you're interested in learning more about this, we have a lot of blog posts about this on the Human Loop website, more detailed guides on evaluation. But now I want to hand over to Brianna, who's actually been doing this in practice, to talk about how Filevine's been building their AI products and how they use Human Loop and evals to make them reliable. So over to you, Brianna.
Awesome. Hey, ML Ops. I've been a huge member for the last few years and I'm really excited to be talking to you. So I'm going to share what Filevine is doing as a leader in the AI and legal space. And really, Filevine is a case management software where we are working with clients, our law firms, from the beginning of a case where they intake a firm to the settlement or the verdict on a case. So everything that happens in between, Filevine holds, from calendars, notes, emails, text messages, all the documents, all the evidence, everything that's happening, we sit on top of as a platform. So we have an enormous unstructured data set that we work with. We were very early to adopt AI in our workflows, and that's for a variety of reasons. Our clients really expect us to be able to amplify their workflow and provide this wonderful experience so that they can get to the itemized details and the pieces that are going to really make their case strong. Remember, law firms, their clients are people who sometimes it's the worst times of their lives when they're coming and working with a law firm. So they want to feel comfortable, content. They want to know that their case is managed and handled. And then, Raza, can you advance, or do you want me to? Thank you. Okay. So really, one of our original AI products was AI Fields. This is still living and breathing. That's one of our most used AI features. This product sits on top of that vast document data store. And what we do there is we process and leverage generative AI and prompts to do extraction and orchestration on top of that huge unstructured store. So with Human Loop, we're actually processing over 1.5 million chat requests. So the times the users come and try to extract data or interact with these documents. Over 360,000 documents went through this process in the last month. And we processed through Human Loop 25 billion tokens of input output. So really, we allow clients to leverage and build on top of this robust prompt library. And this is where evals become like non-negotiable. We are doing such a volume for our clients. We cannot react to like whack-a-mole feedback. And we have to know that every single change we make is going to enhance the feature and that it doesn't cause harm for our clients, right? The other thing, and if you could advance again for me, thank you. The other thing here at Filevine is we have a huge collaboration point with domain experts. So as Raza said, it's not just about the prompt, right? It's about that whole workflow leading up to the process and then after the process of running a prompt or running a Gen AI process. And so we have non-technical subject matter experts. We have existing attorneys, former attorneys, paralegals, users, domain experts that are all working and working through this iteration process. So they start with an idea, and ultimately we work with then technical stakeholders who have the ability to use the API features of Human Loop on the back end to create data sets and then start to validate that these workflows are working. And to Raz's earlier point, and I'll show you, we can actually go through experiments with different variations of each one of those configuration points so we can know what's going to be the best result for our client. If it's speed, latency, cost, we can make all of those decisions comprehensively. And we also allow our external Filevine clients to interact. They are able to do user-defined prompts. So they need to be supported in that, right? Our law firms don't have a lot of time. A lot of these law firms don't have the ability to spin up an AI group to focus on generative AI and best practices. They're working cases, they have large caseloads. They don't have time to go read industry best practices with prompting or prompting techniques. They want to be able to get into FileVine and interact with their data in this chat generative process without having to know how they're doing it or what they need to invoke or use. And then ultimately, something like AI Fields, which I talked about earlier, becomes the backbone for other products. So not only can you extract a lot of detail from your document or your case, now you want to be able to leverage that. You want to draft a demand to an insurance company for that. You want to draft a motion. You want to move that data along so that it can automate your workflow. And so really we have several extraction workflows and chat workflows. We have more than this, but this is a nice example. So on the top, we're inputting document data. We're running a production prompt that we did eval through. We have a great benchmarker standard on that. And then we have the output data that could be it. Somebody could want to leverage and use that, like a medical chronology from thousands of pages of a medical history. And then they can also pass it along to a draft in terms of something they're creating, whether it's a demand or another document. And then we also have a chat workflow where you can interact with all of your content and documents and then continue to move that along for automation. So it's really important that our foundation is strong, and evals is the only way we cement that and make sure that's true. Otherwise, as you all know, whether you've been in a data background or not, garbage in, garbage out. If we didn't do a good job with initial extractions or initial data setup, everything downstream is going to be a total mess, erode trust with clients, and ultimately they're going to have to redo it. Next slide, please. Thank you. All right, so this is an example. I have some screenshots from, pardon me, the Human Loop UI. And so this is where we built a classification model. As you all know, language models are said to be like really great at classifying, right? And generally, I believe this, but we had to go prove it with evals. And so what you're seeing here is all of those purple icons are different configurations of what we fed for token size. So in this case, we did from 4K to 100K samples of documents. Those 4K to 100K is tokens. And we did this on 6,000 documents. And so what we ended up doing is creating a data set that had those different like ETL or prep processes. We're going to feed it 4K. We're going to feed it 100K tokens. We did that because sometimes lawyers like to put a lot in one PDF. And so we needed to understand how many documents are we going to be able to identify and classify within that, and where's kind of an elbow point of we don't need to process more than X tokens. So we set that up. We also, of course, if you've been in data science or data, you have to have a validation set, right? How did you get the right answer and know that it's true? And if you can go back, yeah, thank you. Then really what we're able to do is run evaluations and know how well the model is performing. So on the bottom left, what you're seeing is all of our experiments. So we can actually tweak each one of those pieces that Raza was talking about. The inputs, we can tweak the prompt. We can know exactly what changes we made on the prompt. Like for instance, a confidence score generation metric, and then what impact that had on the prompt output itself. And then we're using those little orange icons are the LLM judge evaluators. And so those are really directional. It's not as tight as precision recall, but what it is a really great indicator to say, like, this is how well it's generally performing. So we're able to do that. And then we are also within Human Loop able to use Python to truly grab a true precision recall metric. So the big so what here is that when we have evals in place and we have the tools to use them both for non-technical and technical stakeholders, we can iterate really quickly. So what began as, hey, we need to classify about 60 categories from documents, we were able to do that very quickly. Our precision recall is in high 80s, and for most documents, it's actually in the 90s, which is really great. And then we were able to jump that to 160 categories with the same high 80s, and then for some, mostly in the 90s for those classes. We were able to jump that up really quickly and validate it so that now we can release a document classification product that then other automations and workflows can be built on with high confidence. In the future, we can continue to add classes to this, and know if we're causing harm. So that's really the power of doing this, is that you can advance to the next slide and I'll kind of wrap up here. But this is the power of being able to go through eval processes. We use Human Loop because it brings together the subject matter experts, the technical folks, and then it creates a safe space for us to really work with our data. And as Raza said, look at it, work with it, and enhance it. So when we started in the early days in 2023, when the recent gen of all the new generative AI models came out, but we started like a lot of people do, and I believe a lot of people are still in this pattern. But we started with hard-coded prompts and code, very hard to change, update, and know what changes had impacts. Subject matter experts were working out of docs or other familiar places because they're not familiar with GitLab or GitHub. It was very vibe check, right? Kind of that initial step for stakeholders, and subject matter experts was like, I have a few, this feels good, but I don't know what it's like at scale. And then it was hard to respond and diagnose client feedback. It was a lot of digging and trying to pull teeth to get that information. And ultimately, right, without something like Human Loop, you have to build every API pipeline to every language model. So if you want to test out a different foundational model or a different company or your own model, it became incredibly cumbersome for you to justify the cost to go build just to test. So now since we've been using Human Loop for well over a year and been having a great time with it, all of our prompts are version control. So we have dev, staging, and deployment environments, which dovetail very nicely with all of our engineering rigor. We have evaluation sets. So for every prompt that we release, we can actually see like what is enhancing. Can we test out new models? What's the precision recall on this? So we do have to continue to kind of go with that foundational validation set. We have searchable logs, which is awesome. So you can actually go see exactly what's happening for specific clients and what they saw and what the issues were. And then we can, through clicks, literally clicks, I can go click a different model and then run it and see how well it's performing. So it's been a game changer, and it allows us to move quickly, have high confidence in what we're making. And ultimately, our clients experience that, right? We're able to just get to it a lot faster. And, earlier it was said in terms of like, you don't want to do harm. This allows you to really be intentional and methodical with your enhancements and your releases so that you're not kind of crossing your fingers. And yes, as was said, like you have to create your own benchmarking and your own utility. You can try to rely on external benchmark, but we all know that it's not going to be an actual applicable fit when somebody goes to use it. So that's how we're using it. And thanks all.
Excellent. Well, we've got the chat that has, I think, unanimously decided that was fantastic. And so there's a bunch of questions that are going to be coming through. Can we just keep this slide up, because this before and after is really cool. I want to know, and Brianna, thank you for coming on here and like talking about the journey with Human Loop and how you're doing it. I want to know, did you have certain statistics that you were able to take to leadership that says, hey, this is awesome and this is why?
Oh, yeah, for sure. I mean, we did a huge boost from that like circa 2023 to this new workflow, basically within months of adopting Human Loop. We went from prompts having like 50% completion, because like it's really hard to get all the details without knowing all that config set up too. We went from like 50% completeness to, for most prompts, we're in the high 80s and 90s. And these are highly, highly detailed prompts. It's not like summaries. So yes, we definitely were. And then clients, of course, experienced the goodness of all that as well. So yeah, we're easily able to justify why we did all this.
Nice. Did you ever get to a point where it was like, hey, there's product metrics that are starting to show also? Like you're saying, if clients are feeling that goodness, is it that they're spending more time, or there's certain like key metrics in the product that you can point to also?
Yeah, for sure. I mean, usage month over month continues to grow with people just leveraging that one product or feature that I showed, where they're using it for kind of their extraction hub. And then we see more engagement in the downstream products that connect to that. So now you can, create documents on top of those data inputs. So we definitely see more usage in that existing features, and then other like downstream dependencies get more and more folks using them and leveraging them, because it just becomes easier when you trust the foundation.
Yeah.
I'd maybe just add there, Demetrius, that we spent a lot of time today talking about the process and development, but actually a lot of the evaluation continues post-production as well. And so you can be getting those product style metrics like usage metrics back into human loop as well to monitor the impact of your changes. So you can also A/B test things in production, not just in development.
Yeah, 100%.
Oh, go ahead, Brianna. Sorry.
Yeah, we can actually look at troublemakers in terms of, oh, that got, poor response. You can do thumbs up, thumbs down in human loop. So it's easy to be able to like peel off, these things didn't work like we thought they would. What do we need to do here? So it's really easy to identify that.
Well, the reason that this is so fascinating for me is because a lot of times I hear folks saying how to justify the spend. AI can get really expensive, and if you're just throwing it out there and you don't really understand that it's making your end user's life better, a la Meta AI, right? And it's just kind of like, why is this here? Some product manager was forced to put AI into the product, and now I never want to use it, and it's just getting in the way. But it feels like you're able to not only attach the evals, but attach like product stuff too. Is that a safe assumption?
100%. Yeah, we really early on skewed this whole product. So it wasn't this ambiguous, like, I hope they use it, right? We sold it and people did buy it because there's a huge automation and value add and efficiency add for law firms. And so, yes, we originally did that, and then we continued to layer experience onto it so that people can kind of walk through the entire life cycle of a case with that efficiency behind them. So we intentionally build that way so that you're not having to, it might be automated over here, but now you manually are doing this drafting piece, right? Like you're able to connect those two elements. And so we continue to do that because our goal isn't to replace lawyers, replace legal staff. Our goal is to supplement and make them an X factor of themselves so they can be and do all the great things that they need to do. They have an incredibly hard job. And so let's automate the things that we can for them.
Excellent. All right. There's a question from Stefan in the chat. How granular should prompts be? How do you define it? Like one action or task per prompt or something else?
Yeah, great question. I would say, honestly, crappy answer, but it depends. Really, how we build is we have what am I looking for, right? And so in the case of an extraction prompt, like we get medical chronologies where we get thousands of pages of a medical history, and we want to build a full comprehensive chronology of somebody's medical history with date visits, physician. So we say this is what the right answer is. We start with that in mind. It may change as we develop, but we have to be intentional about it. So you can start as granular as you want, but ultimately, what is it you're trying to do? And then you can kind of go back and forth through the eval to see if you're hitting the mark. So if you have too many tasks and it just is not doing well, you can easily see that and split it up and start to isolate and identify how you can work through it and get the accuracy on the entire process. So it depends, but start with the end in mind, and then you can really easily iterate to make sure you're hitting it.
A lot of times I will hear folks saying that, especially if they're relying on one provider and they have that working well, but there's some black magic that goes on with the provider and they update something behind the scenes, and then all of a sudden you have to go and relook at your prompts. Are you seeing that? Has that been something that, like, without any warning, it's just like, hey, we're getting alerts. Maybe we have to re-architect our prompts.
Yeah, so obviously we try to be intentional about updating prompts and not so reactive to responding to changes or issues. But yes, of course, we see it. We have the LLM judge and evaluator in place to catch that so that we're not getting inundated with client complaint. Really, what we also try to do is strive for templating and making it so that things are consistent. So we don't have, we have kind of like prompts as code, and we're working more and more towards that instead of having to go figure out what we need to change language on or update verbiage on across all those production prompts. So we try to be as like concise and templatized as possible. So if you update in one place, it's going to be received in other places immediately. Human Loop lets you do that through snippets and tools. So you can just update it once and it'll be in 50 prompts if it was included in that. So yeah, we try to be very proactive, but when we do have to be reactive, we can at least really easily isolate what happened and update it quickly.
Excellent. And are there, what kind of metrics are you using in your eval framework for specific terminology for regulated industries?
Ooh, yeah, that's a great question. So I think from like a data security perspective, like we're honoring all SOC 2, Type 2, HIPAA. We have an enormous amount of due diligence that we have to do. So we honor all of that on that side. And then in terms of what we're doing from a like standard and practice area, really a lot of this is so manually done that we're competing with spreadsheets, we're competing with like PDF, Adobe, and Control F. And so that's where we're really starting to create those benchmarks. And this is a new workflow for a lot of folks. So we're kind of establishing and creating this, but we do have to honor and maintain all of the requirements, obviously, that our clients trust us with, since we have such sensitive data. So I hope that answered the question. Let me know if it didn't, or ping me if you want more.
Yes, there are a few more questions here. Raza, are there any issues with getting stuck in local optima with the eval approach? If so, how can you combat this? Start with diverse prompts?
Yeah, I guess there's two things I would say to that. So one is that the evals typically co-evolve alongside the product and the prompt development. So usually the way that we see people working is they'll like build the MVP of the system, they'll run that over a data set of test cases, and then they'll look at it and they'll sort of notice common failure modes, places the models are strong, places the models are weak. Sometimes they'll be surprised that the models can do things that they didn't know they could in terms of the capabilities. And so it's usually not that the evals get written at once and then people just iterate against them. Usually what's happening is like they have an initial set of evals, and then they're adding new evals to that over time, or they'll notice data points in production that are kind of examples of edge cases. They'll add that to an eval to make sure that the model stays good at those. And so the reason I think they don't end up in local optima is that they're actually evolving the evaluation metrics alongside the prompts. And then the second thing I would just say is that typically people aren't starting with a diverse set of prompts, but what we're starting to do, and I think what we're going to be launching in the near future, is actually we can start auto-optimizing some of these prompts for you. And so you can set up your first version, but once you have the evals and logs in place, we will actually do the search over the space of possible prompts for you and proactively suggest to you how to improve it. So that's going to be launching in beta soon. And if people are interested, just watch our Twitter and LinkedIn. We'll sort of start taking signups for that in the next couple of weeks, in fact.
That sounds incredible. That reminds me of like DSPy type stuff. And how do you get
it's conceptually very similar, yeah.
Yeah. It's like prompting, and there's folks that are saying it in the chat. It's very much like we're trying to figure out the best way to prompt. And it's not really a science. It's not really clear, I guess. It is very much like exploratory right now. And so
there's two parts to it, I would say. Like one is things that look like tricks or hacks or kind of working around the deficiencies of the models. Like, how do I actually communicate with the model? And I think that is best optimized away or will just be improved by the providers themselves. But then there's the second part of just clearly specifying what it is you actually want the system to do. And that's why domain experts end up really being important. And I think that second form of prompt engineering, of having someone who is a domain expert articulate what good looks like and exactly what you're trying to achieve, I don't think that's going to go away. And I think that's where the role of prompt engineering will kind of stay and tend towards.
Excellent. Well, this has been very cool. I appreciate both of you coming on here. And as always, if anyone wants to continue the conversation, then you are both on LinkedIn. And really, thanks again. Huge thanks, Raza, for Human Loop sponsoring this, making it happen. It warms my heart. And you can't get away from me. I'm going to see you in San Francisco soon enough.
Yeah, see you in a couple of weeks. Thanks very much, Dimitrios, and thanks to the community.
All right, I'll see you all, and let's keep it moving, because what do you know? I'm not good at this time thing. I should be a bit more on beat because I'm musical, but that's not how it is today. We have our next speaker coming up from Google. Hello, Afshan. How you doing? Can you hear? Yeah, all right, cool. I hear you. And we've got a talk coming up, right? That's building consumer-facing Gen AI chatbots. Do you want to go ahead and share your screen, and then we will start rocking and rolling? I'll be back in 20 minutes to ask you a few questions.
Awesome. Sounds fun. I know this is going to be great. Hope you guys are having a great conference so far.
Yeah, you haven't seen any of the random videos yet?
I've been tuning in a little bit.
All right. So we'll throw some at it after this talk too. All right, the floor is yours. I'll talk to you in a bit.
All right. Yeah, thanks. Hey folks, my name's Afshan. I'm going to be delivering a presentation on building consumer-facing chatbots. I'm just going to read it out. There's a lot that goes into building production-scale chatbots, but we're going to focus specifically on what it takes for chatbots that live in the wild, that users can interact with, where it's basically a B2C application. It's consumer grade, and we've learned lessons in how to design these agents, how to scale these agents, and how to protect them and preserve your brand safety. So let me just give you a quick introduction about me. I'm Afshan. I work for Google Cloud Consulting. And in short, I help organizations build production scale Gen AI applications every day in and day out. I work with a variety of different companies, big and small, from people who want low code to people who want like robust systems. I largely work with the builders. I work with people who are building first of a kind applications. So there's a strong engineering focus in everything that I do. There's always an emphasis on scaling, and there's always an emphasis on catching the next wave. So whenever there's a new interesting application coming along, you can trust that me and my team will be there. We've done some really interesting work. We built the chatbot for the Paris Olympics in 2024. I've been working with some cool gaming companies on character generation, work with marketing companies on brand creatives, both in the image side as well as for text, using generative AI, doing some cool work with fine tuning. So the list never ends. And here are some of the companies I've worked with before being at Google. Let's dive right in, right? So you're trying to build an LLM agent in 2025. What's the kind of user experience that your customer is expecting, right? A user wants to go on your chatbot and have a very seamless conversation. They want to be able to truly understand. They want to